Hi guys, and welcome back to another video. In this video I want to show you part of the electrical system. I'm starting working on it. It will be spread out in different parts. I cannot start and finish the electrical system in one go. Let me show you what I did, because I already did something, and let's talk about it. So, as you can see, there is a lot of things going on here. So mainly I built this cabinet, kind of, around the wheel well. It's still untouched, so I can move it. There is a main battery switch, and I made this on purpose so I can connect and do maintenance stuff, you know. I will go through, the box with the mains cables. Here you can see my 3 solar charge controller for the 3 solar panel. Those are the wires coming from the roof. DC fuses. This is the 220 volts AC. Positive bus bar with fuses. Still need to mount a few of them. Negative bus bar with the smart shunt. The battery will be here. This is one cell, but there will be 8 of those. Some board that I designed last year based on a project from a guy. I will link his video up here if you want to check out. I took his design and his principal design and I modified a little bit and make my own. Basically, this circuit board works on 24 volts. I have 8 outputs, digital controlled by an ESP8266, so I can switch on and off or use pulse width modulation. Basically, I can dim a light, for example, or control the speed of a fan. Everything will be online on my LAN, and through an app or a web server I can control all the output. It's a bit of automation for my van. For example, this one will be used for lights mainly. This one I have attached some temperature sensors, so this one will be working as a thermostat for my floor heating and for other stuff that you will see in the future. Those bus bars are the cheap Chinese bus bar. I bought those instead of the more expensive one because those are really small compared to them. I know you can argue that, well, but then you need fuses, then you need yeah, you're right, but I like more this situation right here, so I can customize a little bit and not have just that blue big box and work around it, you know. Then those bus bars comes with 4 M8 studs, but the actual bar is not copper, it's brass. So what I did, I modified them. I make my own because I already had laying around a piece of copper, and I made a pure copper bus bar. Here you can see I have a shunt connecting the 2 bus bars together, because this bus bar will be the PV array and the DC to DC charger input. So here will be only input chargers that will be measured by this shunt, and on this one will be the loads, so like all the appliance, the inverter and lights stuff. So I have this shunt right here that will be used by the BMS. I have the SBMS 0. In future you will see that. And on the negative side I did basically the same, but with one straight big bus bar that comes from the Victron shunt directly. So I think this looks perfect for me, because I have just one connection here, and then I can come with the negative wire like this one straight from the bus bar. So yeah. Okay, so now I have some connection to do here for the fuses and the solar charge controller. I'm going to film a little bit of that, and then we will talk about more in depth when I'm going to install the battery and the BMS. That it's really the, you know, the core of the system. Okay, so the solar charge controller are connected, positive and negative. Still missing 2 fuses. I ordered them, so I'm using 30 amps fuses, 6mm wires. And let me explain something, because I saw so much confusion. I saw on the internet so many people be confused around fuses and wires. So basically, this fuse right here, its main purpose is to protect the wire from here to the device. If you want to have a fuse that will protect the device, you need a fuse close to the device. And actually this Victron solar charge controller, they have right here, see this yellow one? It's a 20 amp fuse. Always the fuses is closer to the source of power, and it will protect the wire. So the rating of the fuse needs to be chosen accordingly with the wire gauge. Okay, so same. I have a, like here on the battery, I have a 300 amps fuse right on the positive post of the battery. This is just one cell, of course, but there will be more connecting in series. Then this one with a big gauge wire will go through the switch on the bus bar. That fuse, it's needed to protect all these wires up to the bus bar. And by the way, I'm using 6mm wire for 15 amps solar charge controller. It's way overkill because 6mm can handle up to, I guess, if I remember correctly, up to 40 amps, something like that. But there is a lot to consider when you're talking about, you know, wires, because you need to take in consideration of the maximum temperature they will work, how many are like tied together, if they are in air or inside on a pipe, or you know, there is a lot. I like to stay on the safe side, that's why I'm using 6mm for 15 amps max. There is a 20 amps fuse here and a 30 amps here. The 6mm, I know it's rated up to 40 amps, more or less, so 30 amps it's plenty enough. Always you can put any fuse lower than the max rating of the wire, accordingly to the max amperage your device will draw, or in this case generate. So yeah. Okay, so if you paid attention to what I said before, you know that I made a big mistake. I have to redo those 3 wires. I connected before right here, but it's wrong. I need them on this bus bar, not this one. This is the main one, this is the charger part, because they shan't. So this is part of the game, you know?
A few moments later.
Okay guys, so I did it. This part here, it's done. Just 2 fuses missing. I just ordered it on Amazon, same as this one, 30 amps. And right here it's finished as well. Little cable management right there. Now I'm cutting the cover of these things. I don't know how you call it. Please let me know in the comment how this product right here it's called in English. So cutting the cover, this part it's finished. Of course I'm not gonna use the load output, but maybe in future I can do something with those. Not sure yet. For sure I need to connect all the, let's see, I can show you this white, oh my god. See, under the fuse there is this little port, 4 pins. That's the VE direct port of Victron. I need to connect all of 3 through that port to my Raspberry Pi. Future videos. It's the positive. For the front panel here.
A few moments later.
I'm gonna mark the positive as always with a little bit of tape around the positive, and then I wrap them together like this, so when I'm connecting them I know which one is the positive and which one is the negative, because I have a little bit of tape on the positive. Now you're probably thinking why I'm not using a red wire, so it's easier to see the positive and the negative. Well, I don't have black one, and the price of copper it's skyrocket now, so this does the job. So the charger side of the bus bar, this one, it's finished. I have the 3 solar charge controller, and this one it's the DC to DC charger from the cab. I write here what it's connected, and this part right here it's for now finished. I say for now because I still need to connect the shunt, and to do that I still need to open this up, but for now I can close it. Even this part right here it's full, so I'm gonna close this one. Perfect. Voila. Okay, so this is my workshop, my dad's workshop actually. Here is where all the magic happens. So let me show you what I'm doing, because to be able to finish the electrical system I need to install the battery, but there is another wall that needs to be cut, but I don't know how long it needs to be until I'll make the entire cabinet on the other side and the shower drawer. So I need to build everything, at least the structure, so I can finish the electrical system. Let me show you what I'm doing right now. Okay, so this is the shower box. It's made of plywood, poplar plywood, 10 millimeters the walls and 6 millimeters on the bottom. It's very light because it will slide on the floor, and because of that I glued underneath carpet, so basically it's sliding like this on the floor. But I will also mount some of these, I don't remember how you call those, sliding things, you know, so I can remove it, but with those at least the drawer will be, you know, coming out straight and not getting stuck in the middle. But they are not here to hold the weight, because the weight will be on the floor. I did paint it to prevent moisture to be absorbed by the wood. And then I have the actual shower pan here. Of course, this is the bottom. I glued the drain, so this is my big, huge shower pan. I never seen on any video a shower pan like this big inside a van. Seriously, I may be the first. This one is 80 by 90 centimeters. So now I need to take the shower pan and put it inside. I will use spray foam underneath to fill the gaps. Then on the walls I'm gonna glue foil of vinyl, white gloss vinyl on the side, and on top there will be a rubber finishing string that goes over, like a U shape, that goes over the wood and the PVC, the vinyl, to make it prettier and also waterproof, 100% waterproof inside. So now you may think, what the heck are you doing with the drain if you're making a drawer that slides on the floor? That's a good question, because I spent a lot of time figuring this out, because I want to do this. This is the cap that goes inside the shower pan, standard. It has a little funnel here because it was supposed to go inside this part right here and make a P-trap inside here. I'm not using this because I glue the other part, the inside part, on the shower pan. I'm not gonna use this. I'm not gonna use any P-trap on the shower pan itself. The P-trap will be underneath the van, attached on the floor of the van. So basically, from the bottom of the drawer, remember 6 mm of plywood plus the carpet is 2-3 mm. So let's say almost 10 mm. Then the shower pan itself, it's 40 mm, almost 50 in total. This one will be out when the shower is not in use. So to use the shower, I will pull the drawer out, and then the hole of the shower pan will be exactly a place on the floor where I will make a hole, fixed hole on the floor of the van, of course with a cap that I need to open and close before. And when those two holes are aligned, I can put this funnel into the shower pan like this. So imagine it's upside down. When it's finished, I will put this in, so the water goes inside here. It doesn't come from outside, but just inside here. And as you can see, the funnel sticks out. So this allows me to funnel the water into the drain that will be on the floor of the van. Sounds complicated. When I will be making this, you will see. Of course, the hole in the van, on the floor of the van, is not done yet. I will do that hole at the last, because I want to be sure, you know, where I make the hole. So yeah, that was a long talk. Let me go ahead and see you later.
One eternity later.
Okay, back to the van. What I have here, it's the battery, or it's not a battery yet, it's just a pile of cells. Let me show you. These are Chinese lithium iron phosphate cells, 304 amp hours. They came from Shenzhen Kishu technology. Great cells, not the cheapest one, but quality I cannot complain. Very precisely matched, and I tested them already, charged, discharged. I'm happy, really happy. This batch of cells cost me around 1500 euros. Maybe if I see in future that it's not enough for my lifestyle, I will upgrade. So it's not connected yet, just put it in place. I left a lot of space, as you can see, to make the best contact possible. I push it apart so I will have a good contact right here. So I have here my torque wrench. You need to torque them at 4 Newton meters. This is the main positive bar with the fuse, blue C fuse, 300 amps. Still waiting for the big wires to connect the battery to the bus bar. I ordered 70 millimeters for the mains and 50 millimeters for the inverter. I just did those crimps on those cables. This is 1 millimeter square cable. I'm gonna use those for the BMS and the cell balancer. This one, active balancer for up to 5 amps. The BMS I'm using is the SBMS0, great product. I 3D print case for it, but I'm not sure if I'm gonna use it. So this will be a wall mount like this, or maybe I will make a hole for this, we'll see. So it's an active BMS, so there is no switching inside of here. If one cell will go too much low or too much high on voltage, to protect the battery, this one will put out a digital command to all the devices that I have to stop charging or to stop drawing current. I don't know if I explain myself correctly, but will be more clear when everything will be installed. So let me put all together.